Thank you for tuning back into the Automation Podcast, the world's number one industrial automation product and technology show. Thanks to you, our audience of highly skilled automation professionals. Thank you for being a member of our audience, and thank you for tuning back in this week. Now, before we get into this week's show, I have a couple of announcements. First of all, I still have one seat available in next week's course. You can choose between 2 or 3 days, and you can choose between Micro 800 and Compact Logic. So if you know anybody who needs that training, please tell them to reach out to me between today is Wednesday, April 15th, and Friday, and we'll try to get them into next week's course. I'm located 1 hour out of Albany, exactly an hour from the Albany International Airport. The second thing I wanted to announce is that as soon as next week's class ends, next Friday, I'll be picking the dates for the next in-person hands-on training. So if you have 2, 3, or 4 people you need to send out for either Micro 800 or Compact Logics training, please reach out to me, and you can actually influence the week I pick for the training. With that said, let's now go ahead and jump into this week's episode of the Automation Podcast, where I sit down with Filipe to learn how Reframe is changing the building of homes by using automation. And for you members out there, there's an additional 10 plus minutes at the end with some behind the scene videos and pictures that I know you guys will enjoy. Felipe, thank you for coming on the Automation Podcast. I'm really looking forward to talking to you about all things robotics. I know you've been doing this for a very long time, well over a decade. And but before we jump into that, as you know, as we talked about in the pre-show, my audience is controls engineers. A lot of them have to work with robots. And so, before we get into what we're going to talk about today, can you introduce yourself to our audience?
Sure. Yeah, definitely. And I'm glad to be here. So, Felipe, I was with Amazon Robotics for about 6 years prior to starting Reframe. That was well over 3 years ago. I led their bin picking solution. So, robots doing machine vision, doing picking, and we were deploying these work cells across the country. ABB, Fanuc, Yaskawa, using all kinds of robots there. Lots of camera systems, a lot of it built in house. But obviously, safety came first. So we had a lot of control systems as well to support those work cells. Prior to that, I spent about 4 years doing humanoid and quadruped robots. So I was actually doing motion planning and soft architecture for the DARPA Robotics Challenge with the old, like clunky hydraulic Boston Dynamics robot. And then I also spent a year in Italy doing quadruped, also hydraulic robots. So lots of high speed control there, right? Like 300, 1,000 hertz cycle times. And yeah, so that's it. Fast forward to Reframe. So really looking to starting to look for a way to have a greater impact in this world. I just had twin boys, and the opportunity came
Congratulations.
knocking to yeah, opportunity came knocking to build a company from the ground up. And it's been 3 years on this journey. At Reframe, I lead our manufacturing team, our robotics team, and our factory software team. So everything from PLCs on the floor, displays, to our kind of robotics roadmap and factory roadmap.
Yeah, I think we should take a moment to talk about just Reframe for a second. Like I visited the website to check you guys out, and I think what you're doing is very interesting. But the people who are watching, and we got a quarter of the people who listen, but for the other 75% of the folks who are watching, they see homes in the background. And typically when we think about making a home, a bunch of people show up with the tool belts. And actually, when I was in college, I worked on some construction lots
Nice.
building homes. And they're nailing up the walls and, everything, the frame and then the drywall and the shingles and, that's all done on site. And so you have to drive to all these different sites. And some days you'll go from one site to another site if you don't have supplies. And, some days it rains and it's like if it's really raining and you're working outside, you really can't do much. And so tell people a little bit about, before we get into the assembly line and the robotics and all that and the
Yep.
controls, tell people about Reframe. What is
Yep.
it?
So Reframe is looking to build housing in a factory environment. What's interesting is that, yeah, we're looking to build close to 1 million homes by 2045. So we're building a network of these factories across the country. Now, how does it work? In a lot of other countries, Northern Europe, for example, is a big one. Japan, a lot of homes are fully built high performance in a factory environment. And In the US, only it's a small percent, let's say 2 to 4% is probably where we're at in terms of homes that are built kind of in a factory environment. Our homes are always above or beyond the stretch code for energy efficiency. So we build towards like net zero, like passive house standards. We electric ready every time, right? Like triple glazed windows. But what's interesting about the way we do it, and I'll kind of start with some of the problems today, right? There's a massive home shortage in the US, so the crisis is real from that perspective. 40% of US labor force that works in housing is looking to retire within the next 10 years.
Yeah.
So both my dad and my grandfather, sorry, my dad and my father-in-law are both electricians. They're both like just retired or looking to retire, and I think that that is generally the norm. Um, and then you're in a world in construction where there are over 30,000 different zoning jurisdictions in the US. So even before you get to site conditions and customer preferences, you're in a world that every single project is kind of unique. It is very hard to build things that are repeatable. So from a manufacturing perspective, it's an industry that has seen zero manufacturing improvements since the 70s. So my sweater, this poster, my laptop, anything that you buy today, less than 10% of the cost of that is labor. When you're talking about housing, it's been a 50-50 split since the 70s with zero improvement. So what Reframe is doing is building a software architecture on the back end to take all of that variation that's required for you to build a home and digitizing it. So we're doing that then in a twin, like an additional twin in CAD.
Mhm.
And then we can generate all the artifacts that then can be used through the factory and our operators in the field to then build that home efficiently. What that means, right, is we have the CAD model for a say like a single family home in Devon's. This is a 12 home community we're currently putting together. Uh, you change the model, like how a wall is going to be built. It automatically translates to all of the G code that's running your CNCs, all the recipes that are being used by the robot, all of the instructions, like the drawing instructions that the operators are using on the floor, the shop drawings. All that gets automatically updated through our software. So the cost of designing to that level of definition goes to zero over time. And then we have all of these artifacts that can be used to manufacture these things in a very kind of climate controlled way, right? And then to kind of the point you're bringing up, once I have that, now I can run in a factory environment where I have a roof over my head. I can guarantee climate conditions, working hours. You can kind of change the labor type, right? Because we're writing these instructions now,
Yeah.
instead of you paying $150 for an electrician in Andover, Mass to drill holes to run their wires, you now have a machine do the work. And hey, now when he's doing his step, that hole's already pre-drilled, so he's not thinking about where the wire is going to go. So it kind of completely kind of flips the equation, and it really drives a much higher quality product in the end.
Yeah, and I think you nailed on one of the points. You know, I have my wife, some of the people she works with at the school, their their relatives, their family members work in construction, and they were just complaining at the Christmas party this past holiday that they can't find anybody. There's no youngsters. You know, you think about the youngsters like my grandkids, they grew up with tablets and touch
Yeah.
screens,
Yeah.
right? They didn't spend a lot of time, unfortunately, outdoors doing things and building things like I taught my kids. You know, they didn't do a lot of that. And it's just a sign of the time. So I see what you're doing as a great way of trying to beat the gap,
Yeah.
beat the mass retirement of people in that area, which is already happening,
Yeah.
to still provide affordable homes. But I had a question for you. And, you know, is your strategy a gigaplant factory or is it more distributed manufacturing for the different areas that you'll be servicing?
That's a great question. I'll get to it real quick. I just one hook while we're here.
Yeah, please.
Uh, we do hire master electricians, master
Oh,
plumbers,
yeah,
but
yeah.
on the floor, we also already have a ratio of youngsters, if you will. So we
Okay.
partner with local technical skills.
Perfect.
So Lawrence Technical, right up the road, we already have six of their students every other week. They're on site, and we actually just hired one full time now that they graduated.
Nice.
So because we're very tech forward, robots, iPads all over the place, right? Lots of AI. It really helps kind of drive that new generation to take on the work. And vacuum lift assists, right? Things that also help
Sure.
you move material around. There's a different kind of labor for somebody who's going to climb up with plywood, three sets of stairs, and put it on the roof versus somebody who's just feeding it into a CNC machine with assist. Um, Now, to your actual question, can you repeat it real quick? So
Oh, yeah.
yeah.
No, so is the strategy going forward, and that was all good information, thank you. The strategy, is it a gigaplant like a car company, or is it distributed manufacturing where you don't just have one manufacturing facility where you may have multiple spread out in different regions?
That's a great question. So our coming from Amazon, where we really deployed a lot of fulfillment centers, and we got to a world where some of those we were doing within 100 days from getting the keys, we could get
Wow.
it fully operational. We think a very similar model applies here, where we can build a network of these smaller. We're aiming at 50,000 square foot factories. Each one of them costs about $5 million. But we get to a world that we can then sign a contract for a piece of work, right? Like, say, with the developer, 100 homes.
Mhm.
And then we build the factory in that area to actually support that work. We spit it up and then we continually operate in that factory. And we see so 50,000 square feet is about the size of a garden center in a Home Depot or like
Mhm.
a Walmart. And we see a world where we're building one for every 5 Home Depots across the country. So we really have like large aspirations for this network. And what's cool about that is that then each one of these operations is very localized to that market. So the folks that are working in that factory are the same ones that live in the community. But
Mhm.
it also means that, and this is all about feedback loops, right? This is one of those that the same electrician who's in the factory is the one who's wrapping up that work on the homes in that community.
Nice.
So they're learning and that improvement in the factory processes because we are the same company that goes all the way to delivering the keys. So we have ownership all the way through.
Hey, everybody, I just wanted to jump in here quickly and tell you about my membership program. If you enjoy these episodes and you want to support our work and help us to keep bringing you more, then consider becoming a member for starting at just $5 a month over at YouTube and the automationblog.com. And at both sites, there's a membership link that'll show you all our past videos that we've done that had membership content in it. It's not just extended editions like this episode, there's actually 10 or more minutes at the end of additional video that you get access to as a member. But there's also member only videos I do as well. I may look at pricing on particular products. I may look at unboxing products and different things. I think we've done already 5 this year, in addition to the extended editions of the podcast. So if you want to support us, you want to get access to all that extra stuff, it is only $5 a month, both on YouTube or at the automationblog.com. And with that said, let's go ahead and jump back into this episode of the Automation Podcast. Yeah, that's excellent. A lot of people in manufacturing who maybe worked on just one particular product or two different particular products don't realize that it's not, and I know this is intuitive, but I was in the same boat. It's not affordable to send boxes full of air places, right? And so you'll find in most major metropolitan areas, you will find a mattress company because a mattress is basically full of air.
Mm.
Springs, but
Yep. Yep.
most of the volume is air. Find the same for a lot of the beverages we like to drink.
Yeah.
They have local breweries, there's local bottling, there's co-packs all over the place.
Yep.
And even the cans, like you'll find canning places that just build aluminum cans for all the things we eat. A lot of that is made close
Totally.
because shipping a truck full of aluminum cans is very expensive
Yeah.
because
Yeah.
most of the space is empty. So I'm not surprised that you're not going for the giga plant like they would do with like a high-end vehicle, but that you're doing more of the distributed manufacturing. Now, tell us a little bit about so you're designing and you have designed these plants that are making homes, and I know there's going to be some manual, there's going to be some automated processes. Take us into the plant and tell us about some of the control systems because we get an engineering audience, right?
Yeah.
Talk to us about some of the robots, some of the visions, some of the
Yeah.
stuff you're
Yeah.
doing, in a little bit more detail that will be of interest to our very technical audience?
Yeah. No, that's a great question. So we have lots of aspirations over time to do more and more automation.
Yeah.
Today, we've really picked two processes that we're really invested on the robotics front, but all of our factory production is paperless. Everything is over iPads. We have basically minute by minute access to what every single operator is doing. And a lot of that training comes from kind of the Amazon world, right? Like
Sure.
reducing cognitive load, driving just the right amount of information at the right time for the operator to be able to do his task. But then the nice thing about having that in place is that then you have that feedback loop that you're collecting cycle times, you're collecting OEE, quality checks, all of that can kind of float. And then over time, you can build more and more of this kind of data set that then can be used for all kinds of other cool things. Okay. So across the factory, we do have a few augmentations. We do a lot of like printing, material printing to drive processes. We have a kind of centimeter level positioning system across the whole factory with kind of RFIDs. We use a company called POSIX. So we're starting to tie some of that data to the rest of like the menu processes, like the software processes we have. We're starting to use cameras. So I actually ran the damage detection camera system for Amazon as part
All
of my
right.
time there. Over here, it's much simpler. It's like, are all the nails in the right spot, right? But we're starting to build some of those kind of closed loop feedbacks with IoT devices. Now, on the full automation side, we use CNCs, we use smart saws. So these are pieces of equipment that are off the shelf, and we write a lot of software to just kind of drive them to be able to cut the kits and the materials the way we want them to be cut. On the robotic side, uh, we picked the highest leverage kind of use case we had, which is framing.
Yeah.
Um, and I think I'm very proud of the way we approach that, and I'll talk a little bit about it. So, framing, the act of kind of assembling walls, is about 15 to 20% of the labor that goes into a home. So it's high value. It's very repetitive. It's very kind of strenuous, right? Like you're moving large pieces of materials and blocks and putting them together. If you today are a modular manufacturer owner, you can go to few companies, most of them are in Europe, and you can buy yourself a $5 to $10 million system that will take 3 years to be installed. That looks and feels like a car assembly line. So these are like 25,000 square foot assembly lines with 8 plus robots that do one type of wall, and you design everything custom, and you get that after a year or two, and then you're in this world that if you want to change anything about it, you're going back to them and waiting 6 months for a change
Ouch.
order. Yeah. So what we came up with is a solution that is 800 square feet. It costs about $200,000. It's a single 7-DOF robot arm on a rail, and we use machine vision to scan the kits as they come into this work cell and decide what to do. And I can definitely share videos with you, and I think that would help a lot for your audience as well. But each we print right on the lumber the basically a Ruko marker, so like a barcode that tells the robot which identification for that stud.
Mhm.
Robot scans it and knows then what stud it is, pulls in from the cloud a recipe, and now it knows what stud for what panel for what project, how it has to be put together, and then it goes on to assemble. So the same system can do 2x4s, 2x6s, and like over time 2x8s, LVLs, types of different types of materials. But from an operations perspective, an operator just shoves a cart into the work cell. It's not calibrated. There's no datums, right? Like it's just kind of in the general area, and the vision is really what guides the robot to be able to do that work.
Oh, very interesting. Now,
Um,
does the operator do the pre-cuts? I mean, are you just getting all raw stock in from the supply house, and the operator pre-cuts it and then puts that as a kit? So many of this, so many of that into the cart and puts it into the work cell.
so that's where the software really drives it, right? So we create these kits per wall, and I
Mhm.
would love to share you some pictures of that as well. So there's a different work cell where an operator then cuts these like wrought lumber into these kits, and they can be fed either to a robotic work cell or to a manual framing table or some
Okay.
other process. But everything is defined based on that CAD model that we started with.
Yeah, yeah.
So like one of the triple deckers we built in Somerville, 3,400 square foot building, 3 stories. It's about 176 walls. And
Wow.
what's crazy about construction is that they're all different, right? Every single one
Yeah.
of those wall elements is unique. So there's no repetition. Like some of them have electrical, some of them have insulation,
Yeah.
right? Like it really varies, and that's why this is a very different kind of manufacturing problem than what you see in most of the industry. Okay, so going back to the robot, right?
Mhm.
Robot scans, nobody knows what to build, but we've really wanted a way to be able to build these assemblies without requiring kind of like without limitations of what is possible. So what we came up with is actually the robot on the other side of the work cell. There's this kind of big metal pane. We call it a panel jig. It's a 1/4 inch steel, basically 20 foot by 10 foot plate. And we use magnets from the welding industry. I don't know if you've ever done welding, like the on-off like magnets.
Okay.
Have you? I don't know if you've seen those
I've never,
before.
yeah, no.
So the way they work is it's basically two magnets inside of a container, and you can rotate the top one. So in one direction, they cancel each other out. So there's like no magnetic force, and the other way they complement each other. So you're getting full force.
Mhm.
So they're used for jigging, like while you're doing welding. But what we did is that we basically developed some systems on top of them, so the robot is able to pick them up and place them anywhere within that panel. So now this robot can build a 8 foot wall or a 6 foot wall. It can build a diagonal wall. It can build a window, a truss, because he can place these pieces of lumber and locate them in any orientation anywhere within that frame, and then go back afterwards and pick those magnets out. So that gives us all the flexibility to really push the problem into software without ever requiring any kind of hardware changes to that work cell later on. So that is one big unlock. And then over time, as we do different tasks, so sheathing, so the process of basically putting pieces of sheets on top of those frames and nailing them, applying insulation, applying electrical, all those become kind of add-ons to that same system.
Sure.
Um, yeah. Okay. So robot picks up each piece of lumber, places it with a magnet, holds it into location, and then he comes back with a different tool. So it does a tool change, swaps over, and then actually nails them all
I
together.
was just about to
So
ask that. Yeah.
so during that process, right, the robot picks up a joint. So
Mhm.
there's two pieces of lumber coming together.
Yep.
It squeezes it. So you're locating that joint within the accuracy of the robot based on the drawings where it needs to be.
Yep.
So applying a lot of force on them, and then it fires however many 3 nails, say, to lock that in place, and rinse and repeat across the whole panel. So very much like a master carpenter, we're pushing those joints to where they're supposed to be, even if the lumber is twisted, if it's curled, if it like so we're handling all the variation in the lumber in the same way that a carpenter would. So yeah, we do that. Panel's ready, kick it off, start over. And today we're building about 5 panels a day. We've run it only half the time. And our goal over time, obviously, is to have dozens of these work cells all running 24/7, generating panels. And that's kind of what's the really cool thing about this whole work cell be only 800 square feet, $200,000 is that now if I go to 100,000 square foot facility, I might have like 5 or 6 of these systems.
Yeah.
If I double the size of the factory, I might have 12, 18, 20. But you can really scale that automation and meeting your ROI. So you can really kind of tune that in a way that a large system, you would be building a whole factory around that system, and then you have to level that throughput independently of what demand you have.
Hey, everybody, just wanted to jump in here and let you know I still have one seat left in next week's course. Students can choose to learn either Micro 800, Compact Logics, or both. There are 2-day and 3-day options now available. And I do lectures on both. You're not just going to be sitting in front of lab equipment. I will be sharing my expertise and knowledge and what I learned from talking to Rockwell and reading all the books and updating all my courses. So please, if you know anybody who needs that training, have them contact me. Today's Wednesday, April 15th, before Friday, April 17th, and we'll get them into next week's course. Now, also, if you know anybody who needs hands-on training, but that's a little too quickly for them, have them reach out to me. Next Friday, I will be picking dates for the next hands-on class, probably late May or early June. So let me know if you know anybody who needs, maybe you need 2, 3, or 4 people to come out to training. Have them get in touch with me and you can help me pick the date for the next class. But with that said, let's go ahead and jump back into this episode of the Automation Podcast. Yeah, that's super interesting. So you could definitely see having multiple wall building stations. So if you had to get a lot of houses done quickly, you could build lots of walls. Um, I think it's so interesting. And then when the wall is complete, does the robot take it off the wall, or is that a manual unload?
That's a great question. Today is a manual unload. By the end of the year, we're going to have some automation to help it kind of augment it.
Okay.
But I think that that question, the underlying part of that question that's super interesting is, right, we're all about doing it manually first, understanding the unknowns,
Yeah,
and
yeah.
then over time bringing more and more automation. And I think that that's been very conscious and like we're pragmatic about that. Is like let's focus on the thing that actually drives differentiation, and then over time we decide when and how to automate, and not try to assume things up front.
Well, I can definitely see situations where you will want to augment the automated system with manual labor. There are just good times for that, and we see that in every not all processes these days, but a lot of processes. We'll see people like in packaging, right, where they get a big order and the automated line only can do so many, so they get everybody around. They say we got to pack all these boxes today. The order has to go out, and so everybody becomes a packaging
Yeah,
robot, and they all package the boxes and
yeah,
so on. And so and again too, when something's being serviced, you can always go back to your manual packaging or manual testing. Um, I find that that's a very interesting. So the vision side of things is very important because you have to get the nails in the right place, right? So you not only have to find the pieces, you have to get them lined up, and then you have to put the nails in the exact right places. Is there any yet, right? Is there any like inspection? Is it looking to see if any of the wood is broken, right? Because you go through so much wood, you're gonna eventually have pieces that have a knot here or there that's
yeah,
not in the right
yeah,
place.
yeah.
And do you do any of that now? Is that something you're looking forward to doing in the future?
That's a great question. So today, yeah, so a little bit of about our vision system, right? We use a depth sensor called Zivid. So it's a Dutch company. They're phenomenal. I've used Insenso's, Photoneos, obviously RealSense, all those. Yeah. So this sensor is like millimeter level accuracy, and we take lots of scans of everything that we do. So we
Hmm.
have all that data. We're not currently acting on that data in the loop.
Sure.
So we do record it, and we actually flag when panels are like under or when we split a stud, so we can go back to it. But we've actually just hired not that long ago a phenomenal vision engineer from Aurora. His name is Shane, and our intent is the next like 6 to 12 months to start rolling some of that capability internally. But again, from an architecture perspective, we're really like, hey, let's have the sensor there. Let's spend the money. It's one of the few things that like we want to spend good money on, make sure that we have the right sensor, and then over time you can like really build out all of that QC and QA capability.
Now, what do you think the biggest opportunity here of making homes in a factory? Um, so I think my son just bought a home. There's all these things they had to come in and just fix them, and these all these little things that had to be done.
Yeah,
And I was kind of shocked at the price he paid for his home. Of course, real estate has gone way up over the years, but would you say the advantage here is time to market, time from the time you order a home to you get it done? Is that the major advantage? Um, or I'm thinking it's probably not going to be priced because it's not going to be less expensive. You tell me what is a
actually,
reframe does? What does it
yeah,
do for the consumer on the consumer
yeah,
side of things by automating these factories?
yeah. So we're about 35% cheaper, and we were
Okay.
actually even as a startup, we already made money on our last project. So things are looking very promising from that perspective. And again, right, talking about that labor arbitrage, and then the other thing you need to think about construction, right, is that because it's so fragmented, each one of these layers, these wedges in the process are taking their own markups.
They have to, yeah.
And
Yeah.
for us being vertically integrated, we can kind of roll that all into the same company. So about a third of the cost of a new home is just markups from all the different, because like
Really.
your GC does not have an electrician. Your GC hires an electrician who then hires the support, right? Like it's always like three or four
And they
layers
all
down.
they'll have families to feed, so they all need to make a profit.
Yeah. So being vertically integrated was really the only way to disrupt because otherwise you have to be operating within one of these wedges, and it's really hard to kind of make like meaningful change.
Mm,
Obviously, the drawback of that is that we have to build a vertically integrated company and be experts at all the different parts
yeah.
of the business. But at scale, it all checks out, and it's already we're seeing very good glimpses of that future. So yeah, 35% cheaper, about 2.5 times faster than
Wow.
construction.
I
So
believe it.
even before you get to all the improvements on manufacturing, right? You're in a world that you're building your foundation for a project and the home at the same time, and you're just putting both together. So that triple decker in Somerville that I brought up earlier, we had a foundation set on a Tuesday morning. Friday afternoon, the whole building was in place. So
Wow.
4 days to stack up. It was upwards of, I think it was like 24 modules. So we just had a truck round robin and we just placed them all. And these modules are leaving the factory with appliances installed, lights,
Wow.
windows, right? Like everything's like a high level of finish. And then we're just kind of spending another couple of months kind of finishing up. But even from a neighbor experience perspective, right? Like it's just a burst of energy, and
Mm,
instead of being like a year of like nail guns and trucks and everything coming to your house. Um, yeah,
we had a neighbor build a house pretty close, and I was trying to film, and every day hammering and all this noise. And it's like, when can I record my podcast and do these things? It's substantial. If you haven't lived next to a house that's been being built in
yeah,
a while, it's substantial. But that's interesting. That's very interesting. And you're always going to need somebody on site because people aren't going to live in your factory.
yeah,
Things are going to leave your factory. They're not going to leave as a full big house that won't fit down the road. It has to still there still needs to be some stuff done on the site.
yep,
Also have to have landscaping. It reminds me when you're telling the story about all the different layers in building a house. It reminds me back in the day when I was a teenager, a very long time ago. And the thing to do is you'd get a job at the local department store. And one of the things that always I thought was interesting was if you were to buy like a set of screwdrivers, Stanley screwdrivers. Stanley sold that set of screwdrivers. Let's say four screwdrivers was $2.50. The distributor who bought that um, sold it for $5, and then by the time it got to Sears or Caldor or any of these old they were $10. And it's
yeah,
not because
yeah,
they weren't doubling the price just because they were evil people. Everybody had their own costs and labor,
yeah,
and that's why we saw, in the '90s and in the 2000s, all the big retailers get their own distribution centers, like Amazon, like Walmart's and Targets and all those big. They had to get their because they had to cut out those middlemen,
yeah,
right?
yeah,
They because everybody, all those individual businesses were having to mark it up so much, and so what that's kind of what you're doing. You're trying to drive out some of the middlemen,
uh,
and instead of having so many hands in the pot, you can do a lot of the manufacturing there. Go ahead.
yeah. No, that's a great point. So we're talking about the labor savings, right?
Yeah.
There's also material savings piece here, which is most of the developers that are building, we call it infill housing, right? So inside like near city centers, they can only build, say, like 4 to 20 homes a year, right? Because they're very
Yeah.
limited on the process and they can't grow beyond that. But they are buying from Home Depot, from Lowe's, from your local lumber yard, and they're paying the markup because those guys are buying it from another body that then is buying it up from the. So even as of today, we already are part of a consortium that sells normally to stores. So we get truckloads of materials straight to our factory, and we already got 35% of savings just
Oh
from
yeah.
skipping that last step on that chain. And you could imagine, like, as we scale, how much more kind of leverage we can have along that. And it's just on material, right? Without talking about kind of the labor benefits. Um, and all, yeah.
Yeah, if you're doing a single house, the amount of stuff you can order versus if you're doing 10 houses, the amount, there's the price savings in volume,
Yeah.
if you're ordering that much and
And then,
warehousing capabilities too. Go ahead.
and the waste is another big one, right? So
Oh yeah.
our saw, we cut right across many projects, so we can actually really amortize and optimize for how material is being cut. You do that on site, and the industry as a whole, anytime you go modular, you see like a 30 to 40% reduction. We think we can get an 80% reduction of waste compared to on-site construction. Uh, just because of these optimizations of how do you lay out the sheets to reduce waste? How do you lay out, right? Like, and these are things that your GC, when he's doing it locally, he's going to go to the next project. He's just going to throw everything in the dump and start over again because it's way
Absolutely.
faster than trying to manage that. Yeah.
Yeah, go to any house being constructed, you'll see a lot of scraps all over the place, which so the bigger ones, can be used for other parts, and you can do that all ahead of time. And two, you could probably get longer lengths because you are a factory. You can get longer lengths than 8 footers or 12 footers. You could get longer lengths because you can handle them, and you could actually use those longer lengths very effectively. So I'm thinking for the controls engineers who are listening, um, can you kind of give them an idea of, so right now we're automatically building framing walls, and give them a kind of a picture what you think like in 5 years, where will you be with the automation?
Yeah, that's a great question. So we actually just put an animation I'll share with you as well, of like our 2030 factory. So we don't have enough scale today to get into material movement, but AMRs are generally like a big piece of this future. Moving panels around, moving windows, right? Like lumber kits are a big thing. So that's one area that I'm very excited to start investing on and kind of really drive. There are plenty of other processes that we want to automate. So we're partnering with this company called Okubo. It's an Israeli company. We're doing a pilot later this year for sanding and painting. So this is a
Oh,
mobile robot with a
nice.
UR on it, and it's able to basically actually sand full surfaces and then paint them, which is extremely labor intensive.
Yeah.
So very exciting to do that. And then yeah, on the robotics itself, right? Like installation application, window installation. There's a bunch of other things that we want to over time build different capabilities within that first kind of architecture workflow that I talked about.
Mhm, mhm.
But just as exciting, at least for me, is all of the different augmentation. So kitting is a great one. Like, why have wires that you're cutting to length and then leaving extra and then like trying to deal with it while you can have a robot that is labeling them as it cuts them. So now you know exactly for a life what that wire is going to be, and cut it to the right length and then create the kit with it. So we do some of this today, but like as the future goes on, you imagine, right? Like I'm an operator on the floor. I'm doing electrical. I scan the wall and there's a box that shows up next to me with just the right parts that I need already cut to length, and you're just putting two and two together as you're going about it. So there's a whole other set of like augmentation work cells that we really want to start driving.
Well, Felipe, I thank you for coming on the show and talking to us about how you're using robotics and automation to build in homes, basically in a factory type environment. And I really appreciate you coming on. And next year, if you guys have a lot more automation and you want to come back on and talk about it, I'd love to have you back on.
I would love to share. Yeah, that would be my pleasure. And yeah, thank you so much for having me today, Sean. Excited to see it, and like, I've been excited following your podcast, so it'll be fun to see my own face in there for once. Yeah, yeah, yeah. Awesome.
Well, I hope you guys enjoyed this episode, and I want to thank our members who make shows like this possible. I really appreciate you guys. Hope you enjoyed the extra 10 minutes at the end of the members only extended edition. I also want to let you know if you know anybody who needs training on PLCs, HMI, or SCADA, please reach out to me. All my contact info is at the top of theautomationschool.com. And with that, I want to wish you all good health and happiness. And until next time, my friends, peace.